Hello Janta, welcome back to Vedantu's NEET Physics channel. I hope that everybody is here and able to see me, able to hear me clearly. अगर मेरी आवाज़ clearly सुन पा रहे हो, मुझे देख पा रहे हो तो फटाफट से start making some noise in the chat box. Everybody, फटाफट से वीडियो को कर दो अपने मित्रों के साथ share. Yes, share it with your friends and do hit the like button quickly. And if you are new on the channel, as it's a growing channel, it's a new channel on Vedantu. So all of you do consider subscribing to the channel as well, because we are going to plan and execute all the series related to your boards preparation as well as related to your NEET preparation. Okay, everyone, let's begin. If you all are here, can see me, can hear me, फटाफट से chat box पे start writing yo. Okay, so let's begin, everybody, without any further delay. As I promised yesterday only, we did the launch, and such a huge day yesterday turned out to be 15th of December, the day we start the channel. We come across some internet fluctuations, so I had to redo half of that session yesterday. Okay, and दोबारा जब सेशन करने गया तो मालूम पड़ा कि जेई की डेट्स रिलीज हो गए. आज सुबह सो के उठा तो मालूम पड़ा नीट के डेट्स भी रिलीज हो गए. द नीट डेट्स ऑल्सो गॉट अनाउंस्ड, एंड आई एम श्योर दैट एवरीबडी इज अवेयर अबाउट दैट, right everyone? So before we get carried away with it, yesterday I promised you with the plan of action that, because one thing is certain, or was certain till the time we were talking yesterday, that board examinations are scheduled. They are starting from 15th of February, and we want to come up with a solid plan for ourselves. And I conducted a poll on the community page of this channel. You can go on the community page and look at all those polls that I have conducted. So the maximum vote came to NCERT exercise solution, and here we are. As you can see, today we are doing chapter number 1, electric charge and fields, question number 1 to 17. So do share with all those who are science students. Doesn't matter whether they are preparing for JEE, NEET, or not preparing for any competitive examination. Share with them, because it could be something which will be very helpful for everyone who's around you in 12th standard and studies physics. Okay, so everyone, let's begin. For people who are new on the channel, this is me, or Suri sir. I'm a B.Tech from IIT Bombay, and yes, students who know me from past, they know that I'm called Mogambo on YouTube, because when you will do good in your examinations, Mogambo khush hoga. Yes, and if you want to follow me, definitely you can follow me on Instagram, as well as you can stay connected on Telegram as well. I'm trying to get more active on Telegram. As of now, we do not have a channel on Telegram for V Physics NEET, but very soon we will be creating that, and then we will have like another way of connecting there. I might come live on Telegram as well. Cool. So everyone, yes, some of you might have the question that, are we late? When I say are we late, you might be questioning me that, sir, don't you think that you are late already in terms of starting the channel? Then yes, let me tell you, we are late. Yes, definitely we are late, but we are latest, and that's why we are going to do all the latest things. And what better time for us that NEET dates are already announced, as I was talking about. So everyone, those who are NEET aspirants or JEE aspirants also for that matter, let me show you. I'm sure that you have already received this. So see this, that now NEET examination has been scheduled for 7th of May, CUET right after that. JEE main is happening in the last week of January and the first week of April. First to second week it will go. Okay, everyone. So don't worry. I have one more thing that I want to talk to you guys about, because the channel is for you all. So of course, it's useful when you guys tell me what exactly is your need of the hour. Okay, so everyone, let's go to the channel and let's go to the community page here right away, and let me bring it here. So see guys, all of you, first of all, what we are doing, I'll take just 2-3 minutes and we'll begin. Okay, so first poll that I conducted a day before, maximum number of votes came for NCERT solution, hence the session is happening. And I have received a few comments asking some students to teach purely in English, some students asking to teach purely in Hindi, or not Hindi plus English. So one more poll, please do vote on this one at least, so that I get to know which language exactly is preferred by the students who are watching this channel. Okay, and this poll I will keep like floating again and again, or rather will bring you guys again and again here, so that I have a good data to understand what exactly the audience want. Okay. Thirdly and last one, I've just now done this. So far I've seen 14 votes only, because it was like done just 35 minutes ago. So do vote on this one, because it will give me an idea that now that NEET dates are announced, what exactly my students want me to do. Okay, so many students are here only for boards. That's good. So we will continue to do that board series. But what about NEET you want me to do? Okay, cool. So I hope everybody understands what you need to. And right now we are here on the channel talking about NCERT solutions. So wait and watch. Most probably tomorrow I'll share a plan of action. By that time I hope that many students would respond to that poll. So by that time I'll get a decent idea what exactly is needed by the students, what exactly is the pain area, and accordingly we'll start a series for NEET 2023 as well. Board series will continue, but maybe we'll cut down on the things that I was thinking about to do in boards. We will continue the NCERT series as of now, and once this gets completed we'll go to the derivation parts. Okay, superb, awesome, very well. All those who are here, +1 in the chat box if you guys are ready, because we have NCERT exercise discussion coming up, and first 17 questions today we'll be discussing. Will not take a lot of time. Okay, and you guys can also solve parallelly along with me. So just +1 in the chat box. Okay, let's begin. Anyway, so guys, this is from physics NCERT, directly the screenshot. As it's a new channel, growing channel, I do not have many resources. I am like more or less one-man army. If you would go on the channel page and you will see some of the recent thumbnails which look like are relatively less in terms of resolution also. तो अगर आप वो देखोगे तो आपको पता पड़ेगा कि क्वालिटी ऑफ थंबनेल्स में थोड़ा सा रेजोल्यूशन कम है. वो मैंने खुद पर्सनली अपने हाथों से बनाए हैं, तो इसीलिए I am right now running more of a one-man show, but the whole idea is to help you guys out. Hence the screenshot, but the quality of content is definitely going to be top-notch. Fine, let's begin. So everyone, we are talking about this question which says what is the force between two small charge pairs having the charge value which is given to you here as 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulombs placed 30 centimeters apart in air. Now when I think from board examination point of view, of course you need to write down when you are answering it. You will say that it is solution and you will write what is given to you. Okay, I'm just suggesting you what to do. So you will write what is given to you. You have been given charge Q1, that is 2 into 10 to the power minus 7. I'll do this for the first question. After that, I'm sure that you guys understand how to approach. The second charge is 3 into 10 to the power minus 7 coulomb. The separation between them is given to you as 30 centimeter, or you can say 30 into 10 to the power minus 2 meters. Okay, things that you should already know. It's lack of space, that's why I'm writing that K value, which is assume that it is in vacuum. So this is 9 into 10 to the power 9, and the units will be Newton meter square per coulomb square. Right, everyone? So we'll be solving accordingly now. So we have given values given, and you can also write like to find what you want to find out. You want to find out the force between Q1 and Q2. What's that force? So assuming that this is Q1, this is Q2 separated by a distance r, you can see that both the charges are positive charges. Both the charges are positive charges, right? So that's why the charges will repel each other. So these two charges will apply equal and opposite force. Force on 1 due to 2 and force on 2 due to 1. Both these forces are equal in magnitude. We are going to calculate that now. So when I'm calculating that force, I'll say that the force is K Q1 Q2 by r square, and definitely repulsive because both are like charges. So K value is 9 into 10 to the power 9 Q1 is 2 into 10 to the power minus 7. Q2 is 3 into 10 to the power minus 7. Whole thing divided by the square of this. So I can say that this is 3 into 10 to the power minus 1. So 9 into 10 to the power minus 2. You can write it as 900 into 10 to the power minus 4. That will become 9 into 10 to the power minus 2 eventually. Okay. So 9 and 9 gets cancelled and 10 to the power minus 2 goes up. So you have 2 into 3, that is 6. This goes up, becomes 10 to the power 11. And I have 10 to the power minus 14 also. So the answer finally comes as 6 into 10 to the power minus 3 Newton. Okay, that's what is the answer. And of course the force is repulsive in nature, which we have shown in the diagram also. You can write it separately. Okay, Chinta? So that's our answer. Cool. Let's go to the next question quickly. I'm sure everybody understands what we have done. This is conceptually the same thing जो हम लोग पहले भी पढ़ चुके होते हैं. ठीक है? So I'm not getting into the conceptual explanation as far as the formula is concerned. I'm assuming it's a very basic formula. So that's why we are directly applying it as K Q1 Q2 by R square. Okay. Cool. Let's go to the next one. Now this one says that an electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. So what is the distance between the two spheres and what is the force on the second sphere due to the first one? So you can see that already part 2 can be directly answered because it is giving us the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another. So first of all, you can think of drawing them small spheres. This is 0.4 microcoulomb, that is Q1, and it is placed at a distance say R, and Q2 is minus 0.8 microcoulomb. So magnitude wise double. Of course these two will attract each other. So F attractive. And the magnitude of that F attractive force is 0.2 Newton, and that is the answer to the second question. What is the force on the second sphere due to the first one? 0.2 Newton, and that is attractive force. Okay, let's talk about the first part, where at this distance when they are having the force of 0.2 Newton, what is the separation between them? So I say that the force which is going to be between them is K Q1 Q2 by R square. Same formula, Coulomb's law. Okay. And this is 9 into 10 to the power 9, or let's rearrange first. Usually that is preferred in board examination, that you write R square as K Q1 Q2 by F. So this is 9 into 10 to the power 9. Okay, Janta? And charges are 0.4 into 10 to the power minus 6. Okay, this is 0.8 into 10 to the power minus 6. I'm writing magnitude only, not writing the negative sign here, because that negative sign will only tell us that the forces are attractive in nature. That negative sign introduces this value. Okay, and force is 0.2 Newton. So 0.2 cancels it 2 times, and I have so I can say that this is 9 into 1.6 into 10 to the power minus 6 minus 6 minus 12, and this is 9, so minus 3 it is. So R square can be seen as 9 into 16 into 10 to the power minus 4. Just to make it easy to take the square root, R will come out to be 3 into 4 10 to the power minus 2. That's 12 into 10 to the power minus 2 meters, or 12 centimeters. Okay, Janta? And for B part, we already got the answer. 0.22 Newton attractive force. That's going to be the answer, right? Of course, goes without saying, like in this question, we have written given, what is to be found, diagram drawn, and then solved it. Okay. So likewise, you have to write what is given, the diagram, what is to be found, and accordingly solving it. Okay, Janta? Cool. Let's move on. Go to question number 3. It says that we have to check the ratio of KE square by G ME MP, which is dimensionless, given to you. Okay, so we have to look up a table of physical constant and determine the value of this ratio. Okay, and what does the ratio signify? See, first of all, if I check with respect to KE square, I can say that the electrostatic force looks like KE into E by R square. Okay, and Fg is G mass of electron, mass of proton by R square. So when you take the ratio of these two, Fe by Fg, that is where you get Ke square by Gme MP. So what does this ratio signify? That it is dimensionless, because it is m1 L1 T minus 2 in numerator and m1 L1 T minus 2 in numerator. Hence it is dimensionless, as it is force upon force. That's why it is dimensionless. Okay, when we talk about the value now, you can find out the value. And what is it signifying? It is signifying the ratio of electric to gravitational force between electron and proton, placed at the same distance in both the cases. Okay, so this distance is R, and at R distance, this is the ratio between the two, electric and gravitational force. So let's calculate this value as well. So when we calculate Fe by Fg, it's going to be 9 into 10 to the power 9. The charge of electron is 1.6 into 10 to the power minus 19. You will square that value. Capital G is 6.67 into 10 to the power minus 11 Newton meter square plus kg per kg square. Mass of electron is 9.1 into 10 to the power minus 31. That of proton is 1.6 into 10 to the power minus 27, and actually 1.67, just to simplify this. So when you will solve this, that's the value that you get, 2.4 into 10 to the power 39, and that's a ratio of electric force to gravitational force. And what does it signify? That the electric force between electron and proton is stronger than the gravitational force, much more stronger. And that means from here you can comment that Fe is much greater than between the gravitational force between the two charges, electron and proton. So basically when you place an electron and a proton at a finite separation, अगर आप एक electron एक proton को एक finite separation पे रख देते हो, so the attractive force between them is stronger because of the charges comparative to the gravitational force. And it becomes actually more interesting if you place two electrons or two protons together, because then you will have one repulsive force because of charges and one attractive force because of gravitation. So the repulsive force will overcome the gravitational force, and two protons and two electrons will move away from each other unless the protons are placed inside the nucleus. That is where nuclear forces come into picture, right? Have a look at it, everyone. Have a look at it. Okay, superb. Let's move on to the next one. Now this question says, explain the meaning of the statement electric charge of a body is quantized. Explain the meaning of the statement that electric charge of a body is quantized. Okay, yes Aksa, correct. So just like our currency, Indian rupee, the charge on any object is also said to be quantized, especially at microscopic level. So what is that minimum charge which can be given or taken? We say that when a body has to be charged, it has to either gain the electrons or it has to lose the electrons. किसी भी बॉडी को चार्ज होने के लिए या तो वो इलेक्ट्रॉन्स को लूज कर सकती है या उसे गेन कर सकती है. If a body gains electrons, it gets negative charge. If it loses electrons, it gets positive charge. So we say that the currency of charging is basically charge of electron. So we say that the amount of charge on a system, especially the microscopic system, is n into E, which means what? This is the integer value. You cannot, subdivide the electron. That means a body will have either E charge, 100 E charge, 4 E charge, minus 4 E charge, but it will not have like 3/4 of E charge. It will not have like 0.78 E charge, 0.25 E charge. No, it will not have that. And that is what we mean by the electrical charge of a body being quantized, because the amount of electrons that it can gain or release are only the currency, and integer value of those number of electrons will define whether a body is having a charge which is quantized or not. Okay, so that's the definition. If electric charge of a body is quantized, this implies that only integer number of electrons can be exchanged between the two bodies, and fractional values will not exist at microscopic level. Okay, hence a body possesses the total charge which is an integer multiple of the electron. Okay, now coming to the second one, why can one ignore quantization of electric charge when dealing with macroscopic or large scale charges? So basically, if you are talking about charges which are very close to the charge of electron, then you are actually dealing with microscopic level. But say you start talking about charge which is of the order of coulombs. Okay, we know that charge of an electron, okay, we know that the charge of electron is 1.6 into 10 to the power minus 19. But if you start talking about a charge which is say 2 coulomb, then this 2 coulomb charge will require like billions and billions of electrons. So in that case, what happens? You can assume that when you're trying to place the electrons to charge a body with that many number of electrons. Okay, rather let's talk about a very simple statement that if the charge of a body is becoming 3.2 coulomb, then how many number of electrons will be required? So the number of electrons will be 3.2 upon 1.6 into 10 to the power 19. So you can see that 2 into 10 to the power 19 number of electrons. 10 to the power 9 is 1 billion. 10 to the power 9 is 1 billion. Or 10 to the power 10 is 10 billions, which is more than the number of people on earth. So, okay, so over that also 1 more billion. Power to that is what we are talking about. 1 billion to the power 1 billion we are talking about. So everyone, when you are placing that many number of electrons anywhere, you will be placing it so close that there will be no boundary for you to realize where exactly the electron starts and where exactly the electron ends. That means you will not be able to find out a single quantization value of the electron there. Means when you are dealing with large scale charges, then the significance of that quantization actually becomes very less. So we say that in macroscopic or large scale charges, the charge used are huge as compared to the magnitude of electric charge of electron, and hence the quantization of the electric charge is of no use on macroscopic scale. Therefore it is ignored and it is considered that electric charge is continuous in that case. Okay, so when you are dealing with that big value, then it doesn't matter whether that small currency exists or does not exist. Okay, next one, Janta. So when a glass rod is rubbed with a silk cloth, charges appear on both, and a similar phenomena is observed with many other pairs of bodies. Explain how this observation is consistent with the law of conservation of charge. So very simple thought, everyone. Say if I have a body, a charge, say one of the body is this pen and the other body is, say I have this glove. Yes, I go to gym. So if I consider this as silk cloth and if I consider this as the glass rod, initially both of them are neutral. Charge on this is 0, charge on this is 0. That means charge on this combined system is 0. Okay. Now when you rub this on the silk cloth, then the glass rod loses the electrons which are gained by the silk cloth when you separate plus Q charge minus Q charge, but the total charge still remains 0. That means what? The initial charge on the system, which was 0, still remains 0, and that is why we say that the entire situation is in sync with the law of conservation of charge. Now how will you write it in good words? Please have a look at it. I'll get aside so that you understand also. It says that before rubbing, both the glass rod and the silk cloth are electrically neutral, or in other words, the net charge on the bodies is 0. So when the glass rod is rubbed with silk cloth, okay, the few electrons from the glass rod gets transferred to silk cloth, and as a result the glass rod becomes positive and silk cloth becomes negatively charged. Since the magnitude of positive charge on the glass rod is same as that of the magnitude transferred to the silk, hence the net charge of the system is still 0. So we can say that this is in accordance with the law of conservation of charge. Make sense, everyone? So that's how you need to write it down in your board examination. Whatever you are thinking, you have to put it in good words. Okay, these are usually 1 or 2 marks questions, not more than that. Okay, next one, we have 4-point charges QA, QB, QC and QD, which are located at the corners of a square ABCD of side length 10 centimeter. What is the force on the charge of 1 microcoulomb placed at the center of the square? So यहाँ पे at this point we'll place a 1 microcoulomb charge. At A I am placing a 2 microcoulomb charge. At B I am placing minus 5 microcoulomb charge. This is again 2 microcoulomb charge, and this is again minus 5 microcoulomb charge. So even if I consider there is no charge here, and at the center if we want to find out the net electric field, what will be the net electric field value, Janta? You all can easily answer this. The amount of electric field is repulsive by both of them. EC and EA will cancel out each other. Similarly, ED and EB, because of the symmetry and magnitude, will cancel out each other. So the net electric field at O, E net at O is 0, right? Because of that, the force at O, which is QE net on that charge, which is 1 microcoulomb, will be 0, a simple value, right? You guys are watching this, understanding? समझ में आ रहा है सबको? Okay, moving on, question number 17. Now this one says that an electrostatic field line is a continuous curve. Again, a theoretical question है ये. So that is, a line cannot have a sudden breaks. Why not? It says that electrostatic field lines are always continuous curves. You know that what exactly is electric field, or how do we test an electric field? If we talk about, say, a positive charge, we place test charge Q0 in the nearby vicinity of this charge. And the direction in which Q0 moves is what we say is the direction of electric field of the charge which is tested. So why is it going to be a continuous curve? Because the charge is continuously moving. Q0 charge, the test charge will continuously keep on moving. Because if it will have a sudden break, that would simply mean that the charge has skipped some space, or suddenly the electric field has become 0. Then only the electric field can have breaks. So that is not possible. So electric field lines have to be quite continuous. Doesn't have to be straight lines, can be curved, but has to be continuous. Okay. Second one says, explain why two field lines will never intersect with each other. So at a given line, if we talk about, okay, so if these are your electric field lines, because of a charge, we say that if I go to a given point and draw a tangent, then this tangent gives me the direction of electric field at A. If I go on, say, this point and draw a tangent in that direction, it gives me the direction of electric field at B. Now, as per the statement, if we say have two electric field lines and they are intersecting here, so you will have like theoretically two tangents. A vector cannot have two directions at a given point. That is why they cannot cross each other at any given point. Okay, Jita? So an electrostatic field, it represents the actual path traveled by a unit positive test charge in the field. So if the line have a sudden break, it means that the positive charge jumps from one place to another, which is not possible. And secondly, if the tangent on a point on the line of force is drawn, that is what gives you the direction of the field. So if two field line forces or lines are intersecting, then it will mean that you will have two. Okay. Cool. So if you have two lines of forces which intersect with each other, then it means that your electric field will have two directions, which is practically not possible. Okay. Moving on to next one. It says that 2 point charges QA and QB are located at 20 centimeters, okay, in vacuum. And what is the electric field at the midpoint of O of the line joining AB of the two charges? So this is the situation where you have one charge placed here, another same charge but opposite magnitude. So this one is a plus Q charge, this one is a minus Q charge, and at O we can say that both the electric fields will be along the same direction because field lines go away from positive charge and will go towards the negative charge. So magnitude wise, I can say that EA is equal to EB, and that is KQ by R square, and this value is R, and that is 10 centimeters. So 9 into 10 to the power 9, Q value is 3 into 10 to the power minus 6, only the magnitude everybody, direction already has been found out here. And R value everybody, सबको दिखाई दे रहा होगा, R value is basically 10 centimeter, which is 0.1, that means 10 to the power minus 1. So 10 to the power minus 2 on squaring the value. So what do I get? I get 27 into 10 to the power 11, 11 में से 6 गया तो 5 और 2.7 into 10 to the power 6 Newton per coulomb. So what is the net value? Net value is EA plus EB. That means 2 times 2.7 into 10 to the power 6. So 5.4 into 10 to the power 6 Newton per coulomb. That's basically the value of electric field at O. That's your first part. Second part says if a negative test charge of magnitude this much is placed at this point, what is the force experienced by it? So of course that negative test charge when you will be placing, okay, if this is the direction of electric field and you place a negative charge Q naught here, so negative charge has a positive charge electric field creating here, so will experience a force in this direction. So the force experienced by this charge will be along this direction, and that magnitude of the force will be equal to Q naught into E net, which is EO. So the charge value is 1.5 into 10 to the power minus 9 multiplied by 5.4 into 10 to the power 6. So if I write this as 3 by 2, this as 5.4 and 10 to the power minus 3. So this will cancel it 2.7 times, that means 8.1. So the force is 8.1 into 10 to the power minus 3 Newton. What do you say, guys? Have a look, everyone. I hope all of you understand this. Right? That's the answer that we are getting. Okay? Superb. Let's go to another one. Now this says that a system has two charges QA and QB, both are equal and opposite, and located at A. So I have drawn the Z coordinate because x comma y comma z, x comma y comma z. So this is x z axis directly. So we are looking at the z axis, and question is asking us what are the total charges, what are the total charge and electric dipole moment of the system. Okay, so that's like very easy. The first part, Q net is 2.5 into 10 to the power minus 7 minus or plus of minus 2.5 into 10 to the power minus 7. So net charge on a dipole is always 0. Remember that. Okay, net charge on a dipole is always 0. And when you talk about the dipole moment, so dipole moment is of course from negative to positive charge, and that is Q into D. So that's magnitude wise 2.5 into 10 to the power minus 7. Okay, Chinta? And the separation between them is minus 15 to plus 15. It's like 15 and 15, 30 centimeters. So 30 into 10 to the power minus 2. So this dipole moment is going to be 2.5 multiplied by 30 is 25 multiplied by 3. So that's 75 into 10 to the power minus 9, or 7.5 into 10 to the power minus 8 coulomb meters. And of course the direction is from negative to positive charge. Have a look once again, everybody. Okay, I hope it is understandable to everyone. सबको समझ में आ रहा है. This is what you are expected to solve in your board examinations, or from NCERT point of view, this is what is expected. So of course, again I'm repeating this, that you're supposed to actually present your answer properly by writing that this is given, this is asked, this is the diagram, neatly draw the diagram, and then find out the value which is asked. Please make sure that you are not forgetting this part. Solving is going to be, say, the 50 or 60% marks of a given question. Okay, so if a question is say 5 marks, 3 marks is for solving it, 2 marks are actually for presenting all the things, है ना? तो वो याद रखना है हम सबको. Cool. So everybody, moving on to the next one. An electric dipole with dipole moment given, aligned at an angle of 30 degree with the direction of uniform electric field, and we have to find out the torque acting on this. I think so far one of the easiest of the questions, where it says that this is the direction of dipole moment and say this is the direction of electric field, and they both are inclined at an angle of 30 degree, and torque experienced via dipole in an electric field is given by P cross E or P sine theta magnitude wise. So that becomes 4 into 10 to the power minus 9. Electric field is 5 into 10 to the power 4, and sine of 30 degree is going to become half. So that is 10 into 10 to the power minus 5, or simply 10 to the power minus 4 Newton meter. That's the answer that we get. Okay, Chinta? Okay? So this is the concept that we should know. Our dipole is arranged like this, and the electric field lines are going like this. So that's the answer. Moving on to the next one. It says that a polyethylene piece rubbed with wool is found to have a negative charge of 3 into 10 to the power minus 7 coulomb. Estimate the number of electrons transferred and from which to which. See, of course, if you see that this is your polythene and it is rubbed with a wool. Okay, so if it is rubbed with wool, it gains plus Q charge, it gains minus Q charge. Okay, a polythene piece to have a negative charge, sorry, just opposite. This has got negative Q charge, this has got positive Q charge. So definitely electrons got transferred from wool to the polythene. So is there a transfer of mass from wool to polythene also? I would say yes, because electrons are getting transferred. Okay, so let's just answer option A. We have to estimate the number of electrons which are getting transferred here. So number of electrons are the total charge divided by the charge of the electrons. So that is roughly, I take it as 3.2 into 10 to the power minus 7 divided by 1.6 into 10 to the power minus 19. If I'll take it as 3 and then divide by 1.6, then the exact integer answer which is given in the exercise answer key will not match. So that's why we are just adjusting the value here. So this comes out to be, if you take it above, 2 into 10 to the power 12. Okay, and how much mass gets transferred? So the mass which gets transferred is n into the mass of electron. So that is 2 into 10 to the power 12 number of electrons, each having a mass of roughly 9.1 into 10 to the power minus 31. So that is 18.2 into 10 to the power, this will become, if the value is 11, 20, 19, so 10 to the power minus 19 kg, or we can say it's 1.82 into 10 to the power minus 18, and we can estimate it to be close to 2 into 10 to the power minus 18 kgs, which is a negligible mass. 2 into 10 to the power minus 18 kgs are getting transferred from wool to polythene, which is a negligible amount of mass. You can see the value. So exact value is 1.8 into 10 to the power minus 18, roughly 2 into 10 to the power minus 18. Okay, next one. Speed up a bit. So we have two insulated charge copper spheres A and B, and have their centers separated by a distance of 50 centimeters. Okay, and what is the mutual force of electrostatic repulsion if the charge on each is given and the radii of A and B are negligible compared to the other one? Okay, so if I talk about the first one, that's very easy. It's 9 into 10 to the power 9, the K value. Charge is same on both of them, so 6.5 into 6.5 into 10 to the power minus 14. And R value is 50 centimeter, which is 1 by 4, half a meter. So squaring that will give you 0.25. Okay, or we can write it as 2.5 into 10 to the power minus 2, easier to calculate, cancel out. Okay, so this is 25 into 10 to the power minus 2. Okay, so I write it as 9 into 65 into 65 into 10 to the power 9 into 10 to the power minus 16, and this whole thing is divided by 25 into 10 to the power minus 2. Okay, so 25 goes by 5 times, this goes 13 times, this also goes 13 times, cancels out this one. So I have 9 into 169 into 10 to the power minus 2 goes up, becomes plus, so 10 to the power minus 5 is left. Okay, so everyone, when you multiply that and simplify, close to 225 this value will come out to be. Okay, simplifying the value will give you close to 1.5 into 10 to the power minus 2 Newton. The value of force, 1.5 into 10 to the power minus 2 Newton is the order that you are going to get. Okay, superb. And in the part B, it says that what is the force of repulsion if each sphere is charged double the above amount and distance is also made halved. So listen, this force was kq square by r square. Now you are calculating for k 2q square by r by 2 square, which makes it 4 kq square by r square by 4. That means 16 times kq square by r square, which is 16 times the value of force F, which we'll put here. That means 16 into 3 by 2 into 10 to the power minus 2. This cancels 8 times. Okay, so this value comes out to be 0.24 Newton, and that's our answer. What do you say, guys? That's the answer that you get? Okay. Let's go to the next one quickly, everybody. Now, two insulated charge spheres. This one is done already. Coming to question number 13. This one is done, right? Coming to question number 13. Suppose the sphere A and B in previous question have identical sizes, and the third sphere of same size but uncharged is brought in contact with first and then brought in contact with second and finally removed from both. So listen, it has charge Q, it has charge Q, and then you bring an uncharged sphere in contact here. So what happens? The charge becomes Q by 2 on A, and you have another body Q by 2, let's call it A, this one B, and this one is C. So this is A, this is C. B has still charge Q. Now this goes in contact with that fellow, and what you are left with is Q by 2 on A, and Q by 2 plus Q, which is 3Q by 2, 1.5 Q. Half and half will be shared again. So B will have 3Q by 4 charge. This makes sense? Q and 0. Q and 0, half shared, Q by 2 and Q by 2. Then this Q by 2 goes towards B. They both touch. So Q by 2 plus Q becomes 3Q by 2. Half will be kept with this, that is 3Q by 2. And C will have remaining 3Q by 4. You can add the values again. You will still get the total charge as 2Q. So 3Q by 4, 3Q by 4 is 3Q by 2. 3Q by 2 and Q by 2 is 2Q. Right, everyone? So question is asking us that what will be the new force of repulsion between them. So earlier, the force which we found was 1.5 into 10 to the power minus 2 Newton. Okay, now this was the case when Q square by R square was the case. Now Q by 2, 3Q by 4 by R square has to happen. So this 3 by 8 times the force. So 3 by 8 into 1.5 into 10 to the power minus 2. So when you simplify this, will come out to be 5.7 into 10 to the power minus 3 Newton, because further smaller the force has to become. Less than 1/4 it's becoming. Right, everyone? So answer comes out to be 5.7 into 10 to the power minus 3. Cool. Very nice. Next one, Janta. Now what does this question say? This question says that figure 1.33 has 3 charge particle traveling in an electric field here. So you have this electric field, ऊपर positive charges हैं, नीचे negative charges हैं, and charge 1 and 2 are deflecting towards the upper part and third is deflecting towards the lower part. And if you will notice, this one is deflecting the most. If I call it theta 1, this has theta 2, this has theta 3, then theta 1 is greater than theta 2 and theta 3. Okay, I should have called the opposite one. Let's call this as theta 3, theta 2 and theta 1. So theta 3 is greater than theta 2 and theta 1. So which particle has the highest charge to mass ratio? So we know that the one which will deflect the most will have the highest charge value comparative to mass. So that is why third charge will have the highest charge to mass ratio. As far as their polarity is concerned, that's like very easy. You have this as negative charge, this has negative charge, and this fellow is the positive charge. Remember, the more be the charge to mass ratio, the more will be its deflection. Okay? Because your charge is experiencing a QE amount of force here, which is equal to mass into acceleration, and the acceleration is Q by M into E. So in the same electric field, the one which will have more acceleration is the one which has more Q by M ratio. So that acceleration is also responsible for the change in direction. Okay, Janta? Superb. So answer is particle 3. Let's talk about question number 15. It says that consider a uniform electric field which is this much, 3 into 10 to the power 3 I cap, and what is the flux of this field through a square of 10 centimeter square, 10 centimeter on a side whose plane is parallel to YZ plane. So part A wants to talk about calculation of flux. You have an electric field which has to be found. So this is your Z axis, this is your X axis. This is your Y axis, this is your Z axis. YZ plane, and its normal is along I cap direction. Your electric field lines are also going parallel to X axis, which is I cap. So the angle between these two is 0 degree. So if I want to calculate the flux, which is simply E into A into cos of theta, which is 0 degree here, so that is 3 into 10 to the power 3. The side length is 10 centimeter each, so 100 into 10 to the power minus 4 meter square, and this is Newton per Coulomb. So that comes out to be 30 Newton meter square per Coulomb as the flux. Okay. Second part says, what if the flux through the same square, what is the flux through the same square if the normal to this plane makes an angle of 60 degree with this x-axis. Okay. So part B, when you look at this plane, earlier it was like this, and this was your electric field. Now what happens? The plane has its normal or its area vector making an angle of 60 degree. So this is the plane. This is making an angle of 60 degree with x-axis. So now the new flux will be E into A into cos of 60 degree, which is EA by 2, or we can say 30 by 2. So 15 Newton meter square per Coulomb is the new flux value. Have a look, everybody. Make sense? Cool. Very well. So that's the answer also. Moving on to second last question for today. What is the net flux of the uniform electric field of exercise 1.15, that means previous question, through a cube of side 12 centimeters oriented so that its faces are parallel to the coordinate planes? That means if we talk about the electric field lines, they are coming out like this, they are going in like this. Okay. So do you see that as many field lines which are entering, okay, as many field lines which are entering, that many number of field lines are also coming out of the plane here. Okay. So flux in and this is flux out. So as many field lines are coming in, that many field lines are coming out also. So what is the net flux value? Flux in is equal to flux out. So flux net is equal to 0 for sure. Okay, so maybe the charges are here or the net charge inside is 0 maybe. Okay, so the number of field lines entering the cube is same as that of number of field lines coming out of it. And the last one from this part only, careful measurement of the electric field at the surface of the black box indicates that the net outward flux through the surface of the box is this much. So what is the net charge inside? So using the Gauss's law we can find this out. We know that the charge is going to be the flux multiplied by epsilon naught. So that is 8 into 10 to the power 3, okay, into 8.82 into 10 to the power minus 12. So okay, so this value comes out to be close to 70 into 10 to the power minus 9, okay, which we can say is 0.07 microcoulomb. That's the charge which is enclosed. Okay, this is the net flux. Part B says, if the net outward flux through the surface of the box were to be 0, could you conclude that there were no charges inside the box? So we can say that Q net is 0, but for Q net you can have a plus Q charge, plus 2Q charge and minus 3Q charge. So net charge is 0, but there are charges still present inside. So we cannot say that there is no charge. No, we cannot say this. We cannot say that there is no charge inside. We will rather say that only that the net charge inside is 0. Okay, everyone? So Janta, I hope that this helps you. पहला session था ये हमारा, and I'm also gauging with what speed should I teach, and do tell me in the comment box how are you liking these sessions. अगर कुछ change करना है, speed increase करनी है, speed decrease करनी है, or anything else is what you need, you just have to tell me in the comment box, or this is my Telegram ID, you can message me here personally as well. Okay, I hope that these videos turn out to be helpful for you guys in terms of your board's preparation. As I said, very soon we'll be starting off with our NEET sessions also for 2023 preparation. Reminding you guys again, okay, I'll tell you that there is, okay, just hold on. Just reminding you all once again that in the community I am asking you these questions. So like these people have responded, you also do respond. What exactly do you want? Do you want a mega marathon? Right now the first option and the last option is the front runner. So definitely we want the NCERT series that's going on, and my god, this one is becoming very challenging right now with 24 votes. So I need your clear verdict here, everybody. If you really want me to continue with a particular language, you have to be more precise, otherwise it will be very difficult for me. Okay, anyway Janta, I hope that the video turns out to be helpful for all you all, and I want you people to definitely like the video. अगर पसंद आ रहा है, अगर लगता है कि helpful है, तो definitely अपने दोस्तों के साथ share करो. Do share with your friends also. And yes, if you are new to the channel, need your support, do subscribe, okay, and let the channel grow. Share with as many people as you can. At least share with 5 and ask them to share more 5. Okay, try to make it as reachable to people as you can. Okay, that's the only support that I need from all of you guys, and that will give me the motivation, of course, to do more and to push more, right? और वही motivation चाहिए, that is the motivation that I need to continue. The only motivation that you will need after that is that you have to prepare for the examination in the best possible way, and this will become the one-stop solution for all your physics related worries. Okay, Janta. So on that note, this is Mogambo signing off. I'll see you all tomorrow as well, and most likely I'm going to do an additional session tomorrow to give you a plan of action about NEET 2023. So till then, take care, bye bye, good night, and let's get back to work. Bye bye.